Thanks for your patience in waiting. We'll go ahead and get started now. So I'm Nathan Lubchenko, developer evangelist here at Precog, and this webinar is going to be on analyzing Clickstream data using Labcoat. So we're going to do some restructuring and also some time series analysis. So let's go ahead and look at the agenda. We'll begin with a brief overview of the Precog platform, look at some of the select group of the Quirrel basic operators, see how to do some restructuring of data, do some time series analysis, and then look at a few ways to gain insight from queries like this into customer behavior. Then we'll have plenty of time left at the end for questions. As far as for the sort of speed and pacing of things, we're going to go fairly quickly through the Quirrel basic operators. So if you're already familiar with Quirrel, this will just be a good review. And if not, we'll go ahead and make the slides available so that you can go back through more slowly and see the examples. So first, to see how all the pieces of the Precog stack relate, the underlying piece of the Precog technology is the Precog database, and that is a columnar-oriented database that stores that is schemaless, and so it just supports raw JSON data rather than needing to be in a relational format. And it's specifically designed for doing runtime analytics on immutable data. So these are things like clicks or sensor data or anything like that that's not going to change, some sort of fact of the world that's not going to change. And that's the kind of data that's designed to analyze. So then on top of the underlying database is where we have Labcoat, which is where we're going to spend most of our time talking about today. And Labcoat is the graphical user interface, which allows you to write and develop queries in Quirrel, which is a statistically oriented query language that we'll see a lot more details about today. And then the last piece is the report grid visualization library. And the webinars we've had in the past week that we'll do again in the coming weeks focus on the visualization component, how to create interactive visualizations, and also how to embed those visualizations into your application. So that's just a little bit about how the pieces of Precog fit together. This is a screenshot of Labcoat. Before we go into the live version of Labcoat, we'll just go ahead and see some of the different things that are worth pointing out here. On the left is where your files are stored. So this would be where all of your data is, give you a graphical way to access and think about that. And then on the right, there's tutorial and reference guide. So this is a great way to look up any functions you need to, or otherwise learn how to use Quirrel when you're first getting started. And then in the middle, we have the editor and multiple ways to display the results down below. But before we jump into Labcoat, let's go over some of the basic Quirrel operators. So probably the simplest thing you can do in Labcoat and in Quirrel is to load data, or at least one of the things you need to do before you do much of anything else that's interesting. So the basic way to do that is to use the / command. So you just have the / and then you specify whatever the path to the data is. Some examples we'll be looking at today. We have a conversions data set, and also just some sample fun data from summer games in London. And those would be the ways you would load those data sets up. Frequently, it's very convenient, though, also not to keep using that to talk about that data. So we have an assignment operator, which is : equals, and that allows you to specify some variable name. And it doesn't have to be data you've loaded. You could assign anything else. So Quirrel is a very composable language, so you have the results of some part of a query that you want to chain together and use somewhere else. You can use the assignment operator for that as well. But it's very common in Quirrel to assign the data some variable name. And in the first example we have here, where it's conversions : equals / conversions, it doesn't look like we've saved a whole lot, but we can see how in a much more realistic example, when we had a longer path name, it's going to be much more convenient to refer to metals. And that can just be a good way too, if you have some long customer string, something like that, where you don't actually know what that data is. It can be a great way to organize a query also, so it's more easy to read. Filtered descent is the ability to drill down into various subfields. You can have as many nested JSON objects as you want. So you can use that to organize your data, and the operator there is the dot operator. So if you have data.field, you drill down to that field, and data.field.subfield drills into some subfield in that field object. Some examples we'll be looking at today is conversions has a customer field, and then that object also contains state value. So those would be some various ways. So we're looking at how first we assigned the conversions data to a conversions variable, and then we're able to access that and drill down into those fields. Quirrel also supports a variety of reductive functions, and you just use those by calling whatever the function name is and then wrapping whatever the data you want to analyze in parentheses. So one example of that would be counting the data. It can always just be nice to confirm that all the data you think is there, or the number of simple analytics do rely just on basic counts. You can also do things that are a bit more complicated by drilling down a bit further into some numeric field. You can also do things like sums, maxes, mins, various things like that, which are often useful in composing more sophisticated analytics. We're also going to look at some standard library functions and use a couple of those. Oftentimes, just having some raw timestamp isn't actually the best way to organize our data. So with Clickstream data in particular, using a lot of the time functions in the standard library will help us get a better insight into how our customers are behaving. So the way we import any standard library function is to use import and then 2 colons and the name of the module, and then we could use 2 more colons and import the function name specifically. So that's if we want to just import one particular function, or we can use the asterisk as a wildcard operator to import everything in that module. So currently there's stats, math, time, string, type of, are the various modules we have that you would have to import to access that. Or if you prefer, you could just use the full function name where it would be standard time, hour of day. But it's often convenient, especially if we're using multiple functions from that module, to import them and then use them just like we would any other function. So we'd have an example now at the bottom, hour of day of conversions.timestamp, and that will give us a number from 0 to 23 that just specifies what the hour of the day was. Frequently, we're also interested in augmenting data. So this can be a way to add data to existing data, composed either of constants, or frequently what we want to do is to manipulate some existing data to make it more interesting and useful. So the basic way to do that is use the with operator, and then you just specify an object where on the left you have the field name, and then after the colon you have whatever the new data is going to be. So one example of that is if we wanted to have a discounted price field added to our data, we could just populate that with data from conversions.product.price times whatever we wanted the discounted price to be. Because Quirrel does pairwise matching, we could also have a dynamic thing where rather than having just a 0.85 there, if we had a specific different discount listed there, it would take the discount that was in that row associated with it and give us a dynamically created discounted price. And another example we'll be looking at today is to augment our data with this hour variable that we're going to be getting from the hour of daytime function. The most complicated, but also one of the most powerful operators in Quirrel is the solve construct. The solve construct allows you to compute the body of the solve over and over again for whatever values there happen to be for whatever tick variable specified. So in this example we're looking at here, we're solving on tick gender. And so wherever we get the values for tick gender, which is being implicitly inferred by our where clause that we have in this statement. So we're getting the values for tick gender are coming from conversions.customer.gender, which in this case are just male and female. So what we're going to do is we're going to get the body of the solve is going to be computed for each of those values. So in this case, that'll just be 2 times, and we're going to get a gender, and then we'll get the value male, and then we'll get the count where it's equal to male, and then similarly we'll get another row that is gender and it's female, and then we'll get the count where those values are female. So that's just a simple example of how we use a solve statement. The nice thing about this is because Quirrel is set oriented, it just automatically is going to know all those values and compute it all for us. But because it's not the most intuitive thing if you haven't seen it before, let's go ahead and take a look at another example. So it's easy to extend solve statements for multiple tick variables. And so in this case, we've added a state variable along with the gender variable. So we have solve on tick gender and tick state. And we see at the beginning there, a very common idiom in Quirrel is to include the values that you're solving on. So you return those values back as part of your object. And that's frequently useful because you want to know what the results of those, so you sort of have labels, so you know what the count is for what particular thing you're solving on. And in this case, because we're solving on both gender and state, assuming there are 50 states in our data, we would get 100 rows back. So we would compute the body of the solve 100 times, once for each state and gender combo. One sort of word of caution to add here is because the solve construct is so powerful, it's easy to write very simple looking Quirrel, a very concise statement that will provide a very computationally expensive sort of process. So if instead of solving on tick gender, we instead solved on tick timestamp, and our data had 100,000 unique timestamps or something like that, we would be solving, we'd be computing the body of that solve 100,000 times. So it's not that we couldn't do that; it just would radically change our expectations of how long it would take and what it is exactly we're asking Quirrel to do. So while solve is very useful, it does need to be used sort of judiciously. Okay, so with all of those Quirrel operators in place, let's go ahead and jump into Labcoat to see some examples. So in this first one, let's go ahead and look at this London metals data. And I'm going to go ahead and minimize this tutorial pane just to give us a bit more space to work with. And one nice feature about Labcoat is that when we highlight something, we have the option to just run the selected. So this is a nice way to do debugging and incremental development. So here, let's go ahead and look at the JSON version of that data. And as we can see in the data, we have some variable names that might not be exactly ideal. So for example, we have height in centimeters, which might not be the best name for a variable. And maybe we're also used to having our variables start with lowercase letters rather than uppercase letters. So we're going to look at a way to do some restructuring there. Additionally, if we look at this date of birth field, that's not a ISO 8601 formatted data. So if we parse that into a properly formatted time format, then we'll be able to use all the other time functions on it. So basically what we're looking at is how to do some restructuring to make the data easier to work with. And in this case, we're also going to just exclude a bunch of the stuff that we might not be actually interested in doing. So we're just reconstructing a smaller subset of the data that's going to be formatted as we like. So just walking through this query, the data we just loaded was the Summer Games London medals. We're assigning that using the assignment operator to the medals variable. And then we're going to create a new variable called medals prime. And then assigning to that, we're just having the results of this object here. The first thing we're doing is just simply renaming the height in centimeters variable to height. And then we're lowercasing weight and changing the name of totals to medals. And we're also lowercasing age. And then in this last one, we're actually doing some parsing here. So we're using the parse date time fuzzy to return this date of birth stamp into a properly formatted form of data. So let's go ahead and run that query. And we can see here our properly formatted data exactly as we expect, including having the timestamps done as would be more useful. So another thing we might be interested in doing is how to augment data with dummies. And this could either be for doing some advanced filtering or creating some sort of predictive model like a linear regression. So we might not think that it's actually most important that it's 6 o'clock rather than 7 o'clock, but just the very fact that it matters that it's in the evening. So that's the sort of motivation behind this example. And so what we're doing here is we are going to have a similar process where we're creating the conversions prime variable with all of the data that's inside. But in this case, the main difference is that here we were just taking, we were trimming out a lot of the data. in the restructuring data, but here we're using the with variable, so we're going to get all of the existing data that was in conversions, but augmented with this new data. So we're going to get an hour back. We're also going to get dummy variables for morning, afternoon, evening, and female based on these if statements. One thing to keep in mind when you're using if statements in Quirrel is that you do need to use the if, then, and the else. So you get an if, you have some expression that can be evaluated to a Boolean, and then you have the results if that's true, and else the results if that's false. So let's go ahead and run this query and see what the results look like. So here we can notice that we have the original data plus the new values for female, hour, afternoon, morning, evening. So this is going to be a really nice way to create some custom filters or augment your data for predictive modeling. So moving on to doing some time series analysis. So those are some ways to modify and structure your data, but oftentimes we actually want to do some sort of analysis for a time series. And one of the easiest ways to do that is to begin by importing the time standard library and then creating a conversions prime variable, which is augmented just quite simply with the hour of day. So we're using the with command again. We're naming the field hour, and then the hour of day function is going to get us back that hour. So let's go ahead and see what that data looks like. So once again, using the run selected functionality here, if we're highlighting just what we want to see. So incrementally to make sure we're getting what we expect. And we notice we're getting an hour variable. And you can sort values here by clicking on the column. And we get exactly what we'd expect, values between 0 and 23. And so now we're going to do a solve statement on this 0 to 23. So we're going to get 24 computations of the body of this solve statement. And we can see we get exactly what we expect. And so inside there, we're getting a value for hour, and that's just going to be whatever the tick value is there. And then we're just getting the result of this sum. So we're drilling down into the product.price, and then that's the resulting sales here. A common thing we want to do in time series data is to add date filters. So this next query we're looking at is exactly the same down below here. So we're doing the exact same solve, except what we're doing ahead of time is we're adding these start and end values, which are just some dates where there happens to be data in this sample data set. And then the main thing that's going on is we're, in additional hour, we're also adding a millis variable here. And then importantly, what we're doing is we're just creating a filtered data set here where all these expressions will evaluate to true. So where the conversions prime.millis is greater than the start value we specified, and it's less than or equal to the end variable. So this is just a really easy way to add date range filters into your queries. Okay. Another thing we can do is show how easy it is to extend once you sort of have a few of these basic templates down. You can see how easy it is to extend them. So here, rather than solving on hour of day, what we're doing is instead using the week of year function. And so once again, we're augmenting our data with a with variable, with a with keyword, making a variable called week, using the week of year function on conversions.timestamp, and then instead solving on that week variable. And so here, assuming we have enough data, we should be computing the body of the solve statement 52 or 53 times. So let's go ahead and take a look at that. And over here, we see that we are indeed getting the results we expect. Another thing is that built into Labcoat is the ability to create charts. So the bar chart is currently supported in this format, and we can look and see what our data looks like. So that can just be some really good feedback. There's also this option to export to report grid, which we cover in some of the other webinars about how to create visualizations. So that is how to get the sales by week. which we can see is very similar to the sales by hour, just substituting in a slightly different form of time. And the most complicated query we're going to look at today is how to get the cumulative sales by week. So this looks very similar to the last one we did, the sales by week query, but there's an important difference, and that important difference is in this, in the body of the solve here, in the sales field we're going to be creating. We have the sum of the conversions prime dot product dot price, where conversions prime dot week is less than or equal to tick week, and so this is going to have it so that for each value, you're not going to get just the current week, but all the previous weeks also. And so that'll make it a cumulative sum here. The other important thing to notice about this, though, is because we're using this less than or equals to, this makes it so that Quirrel cannot implicitly figure out where the values from tick week are coming from. And so what we've done instead is we've explicitly referred to them up here in the solve declaration. So we have solve tick week, and then we're explicitly saying, get these values for tick week from conversions prime dot week. And we could use that, explicit declaration whenever we want to. So it's just another way to make sure, and perhaps conceptually that might actually be a little bit easier to figure out where the values are coming from. So just worth pointing that out. Let's go ahead and run this query. And once again, it might be worth looking at a chart to see if the results are roughly what we'd expect them to be. Yeah, and we can see the nice ever-increasing thing that we would expect from a cumulative sales. So let's briefly go over what we've covered before moving on how to look at a couple examples of how to gain insight from these sorts of queries. So we restructured our data, and to do that we turned this data from the Olympics into a smaller subset that was better formatted and parsed appropriately. There's a query to do that. Then we also looked at how to add some dummy variables for either filtering or creating a predictive model for our time series analysis. And we can see how by using the with command, we got all of the original data plus all the augmented data that we added. Then we did some time series analysis. We went ahead and saw how to solve by hour of day, which is a common aggregation we'd be interested in doing. Then this one shows how to also add a date range filter. So it's the same query, but just filtered by the date and the range. And then we saw how to easily extend that into solving on week instead of hour. Or in this final query, we looked at how to do cumulative results instead of just week by week. So now let's see how, if we had queries like this, some ways we might be able to gain some insight into our customer behavior. So for this first one we were looking at, and one of the reasons it's often good to visualize the results rather than just looking at columns of numbers, is that one of the first things that jumps out here is highlighted there, that somewhere in the early afternoon we are having a surprising dip. So we had a fairly normal curve going along, but then have this unexpected dip. And so that might be worth something to be interesting to investigate. Is that some normal consumer behavior, that because people are commuting at that time, they're much less likely to purchase things, or maybe are we updating our website at the wrong time, or there's some sort of other negative factor that's going on that's really affecting our conversions at that point. So that just would immediately jump out as one thing that we might be able to analyze and be interested in. And here is a good lesson in choosing the granularity we're going to analyze data in wisely. For example, above we have the data broken down by month of year. So these are sales aggregations by the month of the year. But down below we have it broken down by week of the year. And two things jump out here that we might have missed if we had just looked at it by month of year. By looking at it by week, we see in the early middle part of the year, there's this pretty significant spike that gets totally washed out in the month by month breakdown. So if we'd been doing some sort of particular sales campaign, we might have totally missed that there actually was more. There was some part of it that was more successful than we thought, and maybe it wasn't as sustained as we'd have hoped, but at least there was some result that we could that's worth sort of investigating what happened around that spot. And likewise, we might be feeling really optimistic in the top graph, but the bottom graph shows that there might be concern up ahead, because even though the growth looks really significant, the final week of the year is some sort of significant concern. It looks like it might be repeating a pattern that happened earlier. And likewise, this is doing a breakdown of conversions by gender. So we have conversions by male and female, and if we'd have looked at that just for the entire year, we might very well miss that there's this period of time here in the early part where female conversions are actually significantly higher than male conversions. So for much of the year and the overall, it looks like males are significantly more likely to purchase this product. But so we might be particularly interested in what's going on in this period of time, what sort of marketing efforts were being undertaken that might have caused that significant change for a fairly prolonged period of time. So those are some ways to gain some insights by running queries like this and doing appropriate graphical analysis of them. And let's go ahead and open it up for questions. So please let me know if you have any questions. Okay, well, it doesn't look like there are any questions at this time. But if anything comes up later or anything like that, please contact me at nathan@precog. And definitely feel free to sign up for a free precog account if you haven't done so already. And there's also lots of documentation that will support, in addition to webinars like this, all of your efforts to get started with precog. So thanks for your time, and please contact me if you want the slides.